All right, so in this video, we're going to be going over practice test one, exercise one, right? They give us a 3 by 3 matrix named A, and they also give us some vector B, right? And then they say that H is the real number, right? So what are they really asking us? They're asking us two very similar questions, right? So they're saying for which value of H, if any, does the system AX is equal to B have either no solutions, right? So AX is equal to B is inconsistent. Uh, I guess they're asking for which values of H will AX is equal to B be inconsistent, and they're also asking for which value, if any, right? Does the system AX is equal to B have an infinite amount of solutions? That's what they mean by many, right? Because you can either have zero solutions, one solution, or an infinite set of solutions, right? You can have a family of solutions, right? So what are we going to do? Like how are we going to arrive at a value h, right? What we should do is we should, I guess, like transform this matrix into something a little easier to deal with, right? Because right now it's going to be very, very hard to decide what value of h works for this because I'm not in an echelon form. I can't really do anything with this matrix right now. But if I can transform it into an echelon form, we're going to be able to make we're going to be able to tell, I guess, a little more easier what H is potentially going to be, right? So that's our goal right now. We want to get it into an echelon form, and then we can start doing the actual problem, right? So what are we going to do? We'll actually have the matrix here. I'm kind of cheating a little bit, but all I did, right, is I augmented A with the vector B, right? So here's A, and then here's B, right? That's all I did there. What our goal is to find pivots and then just put zeros under said pivots, right? So what is a pivot? It's just like your first non-zero entry inside of a row. So where would the pivot be in row one, right? I'm searching and immediately I find a non-zero number, right? -1, that's fine. Anything besides zero. So this is our pivot for row one. What I have to do now in order to enter an echelon form is have everything below the pivot you just found, it needs to be zero, right? So that should be our current goal right now, right? So how are we going to do that? Well, what we can do is we can say that well, I want a zero here, right? I want a zero in row two, right? So what I can do is I'm going to say that row two is going to be reassigned to 2 times row one, right? So if I multiply u by 2, that's what I get. I get -2, right? So then how do I eliminate this? I just subtract it, right? So I just need to I need to take 2 times row one, right? So 2 times row one, and I just need to subtract it from whatever row two is, right? And if we do it right, then we should be able to get a zero right here. If we don't get a zero, then we've messed up, and we need to either review our, I guess, look over our calculations, or review, I guess, or make a different row operation that will actually give you a zero. But this should work, right? So I'm probably not going to have enough room here, so I'm actually going to write it down here. Right, so it's -1, -4, 2 plus h augmented with -4, and then we actually had to change row 2, right? Because we're saying row 2 is assigned to something new. So I'm not just going to copy these values anymore. I'm actually going to do some operations, right? So 2 times row 1, right? So that's going to give me -2, and I have to minus row 2, right? So minus this. This is really just plus 2, right? So plus 2 is going to equal 0. That's good. That means we're on the right track, right? So now for this guy, right, I need to times him by 2. So I do 2 times -4, and I need to subtract him from this number. So a minus right here would really make a +7. So that's +7, right? So -8 plus 7 is going to give you a -1. So I'll put -1 right here, right? So we're going to do now 2 times this minus that, right? So I got 2 times 2 plus h minus 1 minus h, right? So what is that really? That's 4 plus 2h minus 1 plus h, right? So then what do these two numbers give you? They give you a 3. What do these two numbers give you? They give you a 3h, right? And there should be no shame in like actually like writing out your arithmetic here, right? Because if you make an error here, like some kind of arithmetic error, maybe you call this 2, right? Your solution at the end is going to be very, very off, and it's going to be very hard for your professor to give you partial, right? So ensure that all of your operations, all of your arithmetic is good, right? And just like you do a little bit of scratch work. There's no shame in it, right? So we just got 3 plus 3h, right? And then what I had to do here is I had to, times u by 2. So -4 times 2, and then I have to subtract from row 2, right? So I get -11. Right? And then of course, row 3 here remains unchanged because we didn't do an operation to it, right? So I'm going to clear out my room here. And then now, I'm interested in getting a 0 down here, right? We said that this is the pivot. Everything below it needs to be 0. So how do we make this 0? Well, it looks like if I add row 1 to row 3, right, -1 plus 1 gives you that 0 that we want, right? So in order to denote that, what I'm going to do is I'm going to say that row 3, right? That's the row we're interested in creating a 0, right? It is going to be turned into row 1 plus row 3, right? So, okay, now down here, row 1 remains unchanged. It's augmented with now -4. Row 2 remains unchanged. We already had the 0 in the correct place, -11. And of course, we have to actually change row 3, right? So then this plus this is going to give you a 0. This plus this gives you a 1. This plus this is just going to be, well, it's going to be h plus 2 minus 3. So then these two numbers is really the only thing you're concerned about, right? So then it's going to be h minus 1, right? Because then that 2 minus 3 gives you that -1. So I got that h minus 1. And then over here, I have just, row 1 plus row 3. That's going to give you -4. Okay. All right, cool. So we're done clearing out like column 1, right? I need to go ahead and look at column 2 now, right? So let's find a pivot in column 2, and then we can eliminate like the rows under it. Or I guess not the rows, but the components, right? So I'm looking at row 2. This is not a pivot because it is 0, right? I'm looking for the first non-zero number. And then over here I find -1. So I found a non-zero number. So this is my pivot that I'm working with. So that means that this one, it's got to go. It's got to go to 0 if I'm really trying to find an echelon form, right? So how am I going to make this 0? Literally, all I have to do is I have to just do row 2 plus row 1 or 3, right? So row 2 plus row 3. That's what we're going to do, right? So we're interested in changing row 3, right? I'm saying that in order to change row 3, I'm going to do row 2 plus the current row 3, right? Okay, so what does that look like? That looks like, okay, so the first two rows are unchanged. -4, 0, -1, 3 plus 3h minus 11. And of course, now we have to actually do the arithmetic, right? So this plus this is going to give you 0. This plus this ought to be 0, because if it's not, then we screwed up, right? And then, oh wow. And then this plus that is going to, well, let's actually like draw that out, or write it out, right? So I have 3 plus 3h, and then plus h minus 1, right? So then these two are going to give you a 2, and then these two are going to give you a 4h, right? So in total, you get, 4h plus 2, right? 4h plus 2, okay? And then over here, we get, well, what are we doing? We're doing row 2 plus row 3, right? So then add these two up, and then you get a -15, right? Okay. So now we've arrived in the echelon form, right? Because we found a pivot here, so we made zeros down here. We found a pivot here, we made a 0 here, right? And then this is our, well, this can be our last pivot, but then that kind of brings me into my next point here, right? So let me go get rid of this. And let's go ahead and review what we're actually like being tasked with, right? I need to find values of h such that, well, first, such that ax is equal to b has no solution, right? Okay, so let's go ahead and look back down here, right? I'm looking for no solution. So what is a scenario where a matrix is going to have no solution, right? If a row of an inconsistent matrix, or I guess, okay, if a row of any matrix has entered this form, right? So this is like one of your rows. 0, 0, 0, and then you have the augment bar, and then you have some non-zero number, right? So this number here is not 0, right? So think of it as like maybe 1 or -15, right? If any one of your rows has entered this form, that means that your matrix is automatically inconsistent. There's nothing you can do to save it, right? It's absolutely going to be there won't be a solution to your system of equations, right? Because I mean, like think about it. Like what does this even really mean, right? That means that I have 0 times x1 plus 0 times x2 plus every one of the like intermediary x's, and then you have 0 times like we could say xp, right? And then this it's equal to some number, right? How am I going to equate a bunch of zeros to some number, right? I can't. There's no way. That's why if a row enters this form, there's no hope, right? Like your matrix is going to be inconsistent. So with that thought in mind, what value of h can I get to enter a form like this, right? Because that's what we want. We want to find the h that gives you no solution, right? So if we can set this like a sort of term here equal to 0, then I enter this form. Then I get no solution. That's exactly what I want, right? So what am I going to do? I'm just going to equate that component, that constant, equal to 0, right? And I'm going to solve for it, right? So then 4h is equal to -2, and then h is equal to -1/2. So what does this mean? That means that if h is equal to -1/2, then this term here is equal to 0, and then I enter this form, which means that I have no solution when h is equal to -1/2. Right? So then now we've just found the number, or I guess like the value h that creates this no solution scenario. So now with the same augmented row operation performed echelon form matrix, how can we find the values of h, if any, such that ax is equal to b has infinitely many solutions, right? So when does a matrix have infinitely many solutions? Well, to keep it brief, it's when you have a free variable, right? If you have a free variable, right? So let's take this matrix right here. So I got 1 0 0 0 1 0, and then let's say that there is a bunch of zeros here, right? And these don't necessarily have to be zeros here, right? So let's spice it up a little bit. Like, you can be 3, you can be 4, right? The fact of the matter is, like, okay, so let's look for pivots in this matrix, right? So I look at row 1 and I see that, this is the first non-zero entry. So you can be my pivot for row 1, right? I look over here for a pivot and I find this 1 here, right? So you can be my pivot for row 2, right? But then I look at row 3 and I don't have a pivot, right? Like, that you're 0, and you're 0, right? So what does that tell me? That tells me that I have a free variable, right? So really, if you have a column that doesn't have a pivot, then you have a free variable, right? And if you have a free variable, what does that mean? That means that, x3 could be equal to any t that you want, and you'll still be consistent, right? So what does that mean? That means that you have an infinite amount of solutions, right? You have an infinite well, I guess like you have a family of solutions, right? Because you can allow t to be whatever you want, right? If t is -1, then I have a solution. If t is 1, I have a solution. Now it's gonna, the actual solution is gonna change, right? Like, so like if we solve this matrix, right? If I have, x2, right? So now I'm looking at like this like third or second row here, right? So if I have, like x2 plus, 4 x3, but what is x3? It's t, right? That's equal to 0, right? Because we're imagining that this has been augmented with the 0 matrix or vector, right? So then we get x2 is equal to -4t, and then if we go back here, right, to the first row, what do we get? We get x1 plus 3x2, but what is x2? It's -4t, right? and then plus, it's going to be 0x3 is equal to 0, right? Because, like I said, it's been like implicitly augmented with the 0 vector, right? So then if we solve for x1, then we get x1 is equal to like what, like 12t. So then what's our solution? Or what's our solution set rather? X is equal, or I guess, yeah, sure. We'll say that. It's just going to be equal to this, right? So I have 12 here, and then I have -4 here, and then I have a 1 here, and then, times t, right? So I can come up with multiple solutions, right? If t is 1, then my solution is 12, -4, and 1, right? If t is like 2, right, then my solution is 24 and -8 and 2, right? And then you can just keep going on. What I'm saying is that there's not exactly one solution to this matrix. There's an infinite family, right? There's a infinite amount of solutions to this matrix. And why is that? It's because we were allowed to have a free variable. How did we get a free variable? It's because this column didn't have its own pivot, right? Okay, so let's bring that idea back to our actual matrix, right? So if I allow, what do you call it? Or I guess like if I want to try to find a free variable, how's that going to work, right? I have a pivot here, and okay, so remember, if this guy is equal to 0, then we're inconsistent, right? Because we entered that form. But then if this guy is anything besides 0, right? So imagine h is equal to 1, right? So if h is equal to 1, what do I have? I have a 6 here, right? But then if I have a 6 here, right? So let's just cross that out. I have a 6 here, right? I'm looking at my row 3 and I find a pivot, right? That's not a free variable. That's not a free column, right? I found a pivot, right? Which that means I have exactly one solution, right? I don't have that freedom I had here, right? I don't have this free variable at all. I have exactly one solution, right? So that means that there actually isn't any h's that satisfy the fact that there would be infinitely many solutions, right? Because I can't produce a free variable. If this is 0, I got no solutions because I entered the form. And if this is anything besides -1/2, right? Then I get some non-zero number here. I get a pivot here, which means that I have exactly one solution because these columns would be linearly independent, right? So what we have to say here is that there is just like there's no value h such that that is true, right? I guess like as a C, if you wanted to find out for which values of h, if any, does it have one solution, you would just say that h was not equal, or I guess yeah, exactly. Like, h is not equal to -1/2, right? For a single solution, right? That could be your C. But yeah, I mean like that's that. You just want to translate or just like transform this into an echelon form, right? And then and only then can you really make some inferences about what H could or could not be. All right. I hope that helped.